Okay, so this video is about a concept that you guys seem to be struggling with, the shorthand notation part, also called the noble gas notation. Yonzies. Or shortcut notation. That's the one that uses your noble gases, which are found here on your periodic table. They're over here in group 18, which means they have 8 valence electrons, which is what makes them stable. And because they're stable, they don't ever change. So just like you guys have your abbreviations for things, scientists use these noble gas configurations as abbreviations for the configurations that come for these bigger elements. So we're going to pick a fairly big element and go from there. So let's do one of the bonuses from your test. We had bismuth, so that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and this just follows your diagonal rule. At this point in the course, you guys should be able to be doing this. Just to save time, I'm going to do it for you. Now, even for a really big element like bismuth, where you may have not had the most experience writing that big, because generally I'll keep it fairly small for your tests and quizzes, but it's the exact same idea. That's why I made this your bonus question. Just bismuth, you know how to do it. This was just taking the process you learned and making it a little more macro. 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, and then finally 6s3. So huge configuration, just took us about a minute and a half to write it. So yeah, instead of writing this each time, scientists use your shorthand notation. And before I forget, we need to go back. Helium is the exception to the noble gases. It's the only one that's not in the p block. It's in the s block, and it doesn't have 8 valence electrons. It only has 2 valence electrons. I've mentioned it before, and we'll say it again right now. Hydrogen and helium are the redheaded stepchildren of the periodic table. They don't really fit in with the rest of the pattern, but since they're the 2 most common elements in the universe, we can't just ignore them. Okay, small divergence. Now we can hop back. So what your shorthand notation does is it takes all this extra stuff at the beginning that never ever changes. Because it doesn't change, we can use our abbreviations for it. Like for you guys, IDC will always mean I don't care, and LOL will always be laugh out loud, which is a throwback to when I was in middle school and high school and instant messenger was a thing. Hooray, you guys are old just like me. Okay, so back to our shorthand notation. In the periodic table, these noble gases, the configuration for neon, let's clear up some space. Neon is 2p6, argon 3p6, krypton 4p6, xenon is 5p, p6, and finally radon is 6p6. Now again, with the exception of helium, because helium doesn't fit in, we have a pattern here. All your noble gases end in a p6. Since the p6 is the end of your energy level, and in order to be stable, you have to have that entire energy level be full. That way it doesn't want to change, it doesn't want to gain or lose electrons, which we'll get into more in the next unit with bonding. p6 means a stable final configuration. Now, the way to do the shorthand notation, finally getting back to the task at hand, is we're going to take this information and we're going to cut out a whole bunch of this. Now, the trick I told you guys was find your final P6 in your long notation. So here we have an S3. Oh, whoops. That's totally a mistake. That shouldn't be S3 at all. That should actually be P3. Why didn't you guys remind me? Jeez. What jerks. I'm just kidding. That's entirely on me. My bad. Okay. So here you have a P3. So that's almost a P6, but it's not a P6. Chemistry is a science of exact. So close enough doesn't work. So skip it. D10, not a P6. F14, not a P6. S2, not a P6. P6. Hey, there we go. That's pretty good. So we're going to use this, and then all the way back to the beginning. So the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6. We're going to take all that, and we're going to shorten it down to this. Look at your 5p6, then xenon. So make a bracket, xenon, bracket. So all of this right here can be shortened down to this. Since chemists who are in the know that this xenon configuration really means 1s2, 2s2, 2p6, etc., instead of having to write it all out, they shorten it, they abbreviate it. This is the scientist nerdy version of LOL. And then after that, all you have to do to complete bismuth is just copy in what's left. 6s2, 4f14, 5d10. Okay, and then we're out of space, so we're going to boop, sneak this guy in down here. 6p3. So to save time and space, we use our shorthand notation. Now we're going to use this on a smaller element just so it doesn't have to be so crazy. We'll do a fairly simple one. Let's do calcium. Now, rather than writing out the entire thing and then turning that into shorthand notation, which defeats the purpose of doing shorthand notation if we're just going to do it the long way, we're going to really shortcut this down now. So calcium is atomic number 20. So go backwards until you find the first noble gas. 19. So potassium, not a noble gas. So go hop all the way over to 18. Argon. That is a noble gas. Okay. So that's what goes in your bracket. Argon. Now, the configuration for argon is 3p6. Now on your not your periodic table, on your diagonal rule, the faster way to do this is find your 3p energy level. And then look for what comes after that. After 3p is 4s. 4 and then s block. And then how many positions into the s block are we? 1, 2. So the shorthand notation for calcium would be argon 4s2. Now, if you're feeling snarky or sassy, you can go through and do it the long way, 1s2, 2s2, all that. See if I'm right, but spoiler alert, I am. So you can check up on that if you don't believe me. And this is just using your diagonal rule. This is the faster way to do it. This is the way I told you guys how I learned how to do the table, where I had to memorize this is the S block, this is the D block, this is the P block, this is the F block, and then kind of like Battleship, use coordinates to find it out. So use your diagonal rule, memorize these 5 configurations, shouldn't be too hard, it's just 5 things, and shorthand notation becomes a lot easier. You need to know this for the next unit and your take-home test that you're getting next week, because there's a good chunk of your test where you have to write shorthand notation. So make sure you know it. If you're not getting it, you guys know the process, come to tutoring. You have got to put in that effort if you want to be successful. We can do more examples, we can try different explanation, maybe we can even find a different video, even though these are the best videos in the world. But, yeah.